Some salts are soluble in water, whereas some are insoluble. In a previous lesson, we learned how to make and isolate soluble salts. In this lesson, we will learn how to make and isolate insoluble salts. Let's say you have been given two solutions, sodium iodide and silver nitrate. These two salts are soluble in water, so aqueous solutions are formed. Add silver nitrate dropwise to sodium iodide, and you will notice that a bright yellow solid is formed. This bright yellow solid is known as a precipitate, which is an insoluble solid formed from combining two solutions. This is known as the precipitation method. Sodium iodide and silver nitrate have undergone a double displacement reaction, whereby the sodium ion and the silver ion have switched places, creating silver iodide and sodium nitrate. Since sodium iodide and silver nitrate are soluble in water, they form aqueous solutions. In the reaction equation, we represent this using AQ in brackets as a subscript right after its formula. Here is a big question. We know that sodium nitrate and silver iodide are formed, but how do we know which is the precipitate? To do so, we must refer to the solubility table as we have learned in a previous lesson. You may know the solubility rules off by heart. All nitrate salts are soluble in water. All iodide salts are soluble in water, except when combined with lead and silver. Therefore, silver iodide is insoluble in water and is that bright yellow precipitate formed in this reaction. Referring back to the equation, we represent this by writing AQ in brackets as a subscript after sodium nitrate, and S in brackets as a subscript after silver iodide. To isolate the silver iodide precipitate, we filter it through a funnel lined with filter paper. Since it is insoluble in water, we can rinse the contents of the beaker with distilled water to ensure that we get all of the precipitate produced. Distilled water is simply water with most ion impurities removed. This filtration process separates a solid from a liquid. The solid collected is known as the residue, and the liquid that the solid is separated from is known as the filtrate. Are you ready for a challenge? Let's grab a pencil and a piece of paper. Predict the products for the double displacement reaction of barium chloride and potassium sulfate and write the reaction equation. Remember to include the state symbols and to fully balance the equation. The answer is, did you remember to balance the equation? And did you get the correct answer? Using the solubility table, we can see that almost all chloride salts are soluble in water, so potassium chloride in water forms an aqueous solution. Almost all sulfate salts are soluble, except for a few, with one of them being the barium sulfate precipitate. So, the reaction equation, including all the state symbols, is this barium sulfate precipitate is in fact so insoluble that one can ingest this and have it safely pass through our gastrointestinal tract without being absorbed by our bodies. It is used as a contrast agent to image our gastrointestinal tract using X-rays. This is not the only method to form an insoluble salt. Another method is by the direct combination of the constituent elements. Insoluble salts can be formed using two methods, via precipitation or by the direct combination.